And welcome to Inspirational STEM. How to find the end behavior of polynomials. Another problem from the OpenStax pre-calculus book. Let's go. So here's a chart up here of the end behavior of polynomials, but let's go ahead and take our problem up here and distribute it first because we want to know what the total exponent, maximum exponent value is. So 2x squared times 1 is 2x squared, and then I have 2x squared times 3x plus 2x squared times negative x squared. Okay, so I'm going to go ahead and simplify that. So I'm going to 2x squared times 3x and multiply the numbers and then the exponents, add the exponents, so we get 6x cubed. Same with the next one, we get negative 2, so x squared and x squared, the exponents will add up, so it becomes x to the 4th power. So this is our final polynomial after distribution. So let's write it down in descending order so we know which is the largest exponent value. It seems here that negative 2x to the 4th power is the maximum exponent value that we have here. Okay, so that is going to determine the end behavior of our polynomial because that's the one that's going to grow the largest as x increases. All right, so let's go ahead and look at our chart here then. If you go up on top here, right hand side top, you see negative x squared has a negative coefficient and a positive even exponent. So this is the same as that. It has a negative coefficient and then it has an even exponent. So what it's going to essentially behave like the top right hand graph where you have the parabola which is facing downwards because of the negative exponent and coefficient, and then the exponent being even, it's going to have the same shape of facing downwards as the example of our behavior chart up here top right corner. So let's go ahead and write our final answer for the behavior then as x approaches positive infinity, that gets larger and larger and larger, negative f of x becomes negatively larger and larger. As x approaches negative infinity, f of x becomes negatively larger and larger and larger and larger. So that's going to be our final answer for this particular problem. And so you see how we matched it up with our chart up here and how this is like the minus x squared and type parabola, and here I use Desmos to go ahead and chart it so as you see the behavior of that. So thank you very much for watching.